Everybody. This is DCG's development update. We are here with the platform teams, the platform team, the core team, and the mobile team. And we are planning this session for 1 hour. Please, if you have any question, feedback, let us know in the chat below, but please use a Q or question prefix so we can answer them in the dedicated Q&A session at the end. All right, let's jump in. Let me find Zoom and sharing the screen so we can start with the platform teams.
Sounds good. Thanks, Balash. You didn't say without further ado this time.
Yeah, I carefully avoided.
Oh, okay. Well, without further ado, I'll start. So we had me, who was basically focusing on masternode voting, and a few other reviews in the team. Lukasz helped towards the end, and he's been helping on the SDK part for masternode voting. Ivan's been working on platform reviewing and trying to find ways that it can be attacked. He also took over the one of the last big things that we knew we needed to do, which and we've been posting on it, I think on the supplemental proposals, which was that we needed to that we knew of a potential attack vector with identity create. So he's been working on that. Lukasz has also been working on TenderDash, and he'll give an update there on a few improvements. Paul been working on continuing to work on strategy tests and the platform TUI. Evgeny has been working on the GroveDB visualizer, but he also helped out Odysseus with StateSync. StateSync has had a big improvement from the last review, so we're very happy about that. One thing to say though is that Evgeny is not available today, so he won't be able to do a demoable update of the visualizer, but he'll do it in next review. Okay, let's start with TenderDash then.
Yeah, hi. I did some fixes to TenderDash because basically we are on a stabilization phase right now. First fix was about some concurrent map iteration. So we had some map data structure, and in some edge case, we catched a bug where we were modifying that map and iterating over it. It was a map of nodes to which we are connected, but the general issue was, sorry, map of channels that we use when we connect to nodes. But the generic bug was that basically we didn't lock it correctly, so it's fixed. Also, we added some improvement in terms of how we detect quorum hash mismatch. When we start a platform, when we replay transactions, we have hit some bug, and that was caused by a hash mismatch between the query and the quorum between data on disk and the quorum hash that we got from Drive. So we improved error handling there, and also some logging improvements to decrease verbosity of some logs to produce less logs. And yeah, another thing that I already started previous sprint, but just finalized now, was to limit transaction gossip between peers. When we have full mempool, or maybe not full, but when we have some items on a mempool on peer 1, we just gossip transactions from that mempool to other peers, but we need some traffic shaping. Previously, we had a traffic shaping for that was just limiting global performance, global number of transactions that can be gossiped to all peers. Right now, each individual peer has its own limit, so it should be like it should behave better, and we should be able to better protect against attacks, denial of the service attacks from one node that is just spamming us with transactions. Yeah, and another small fix was that if some time passes since the start of the platform, on a replay, we might receive in Tenderdash requests to update validators, but without the public keys of these validators. That's because the core might remove old public keys for validators and just leave the threshold public key that is needed to verify the commits, so the blocks. But the individual validator public keys might not be available. So we didn't allow this situation previously, now we allow that, so it should work. Yeah, and there's one bug that we have hit on testnet some time ago, but right now we weren't able to reproduce. Some issue, maybe timing issue, maybe a race condition is making a master node to halt, and it looks like the votes are stuck and are not processed, and some internal queue is full. So basically we need to reproduce it with a bit bigger log level, so on trace log level, to see exactly what's happening there. And we didn't manage to reproduce that so far, so it's on hold. But yeah, we need to get back to it. And I also did some fixes to platform, also small bugs, but for example, the SDK had a bug in error handling in one place, and we got that from users that doesn't work correctly. Because it was waiting for timeout instead of returning the error early. Also, some build script wasn't generating data correctly for the API, for DAPI gRPC. The script is translating protobuf definitions into actual Rust code. And due to various configurations of the Rust features, that generated Rust code was basically overwriting other. So if we run that generation for one set of features, then for another set of features, the former will overwrite previous run. So basically it was non-deterministic build process as a result. It's fixed right now. And also I did some work on CI to help Evgeny with dependencies for some test crate that is needed for JSON schema testing. And just a few days ago, I joined SAM with Dash SDK support on masternode voting. And big part of these bugs and fixes that I did was due to our testing of the platform on testnet, where I spent quite much time on investigating of what's happening and helping recover the testnet from various issues that we got there. Triggered by out of disk issue. So we decided not to. So after cleaning the disk, the system didn't start cleanly. We decided to just spend time to understand the issues instead of wiping it and restarting the devnet, and it's up and running right now, except for one master node, which we decided we don't want to spend more time on, and we will restore it after we release new drive version, which will require cleaning of the wiping the platform anyway. So that's pretty much it on my side.
Thank you very much. Shall we continue with Sam? and Mastodon voting?
We shall. And I am back in video. So I was very hoping that we would be done. We are not done yet with Mastodon voting, but we have made considerable progress. I think 2 weeks ago, I reported that the PR was at around 13,000. It was either 11,000 or 13,000 lines of code. Right now, we are at 20,000 lines of code. So this is actually going to be, and this is without any auto-generated code, is in, well, maybe like 500 lines. But in the past, big PRs that were like 30,000 included about half an auto-generated DAPI gRPC code, but now we do no longer include that in the amounts. So yeah, this is one of the biggest pull requests that we'll have ever done. It's kind of fitting because it will be the last big one. Yeah, so 2 weeks ago, we had vote structure done. We had the contested unique indexes and the data contracts done. We had the processing not done, and now it's done, and it's been tested. So that basically means that when you put in a contested document, it processes it completely correctly and puts it in the it creates a valid a voting poll and a specialized balance, and yeah, that's all done right now, so that's pretty nice. While I say it's done and we have written tests about it, we are going to have to test it more in depth once we have testing in the platform TUI. So, there might be a testing phase after everything here is complete. But individual tests have already been written. So then we have Masternode vote state transition validation. Yeah, we moved from about 80% to 90%. And all of these that have like significant progress, we're going to actually detail like what happened inside of them in other slides. So the Masternode vote execution, proofs, and proof verification, that actually was already done in the past. So nothing happened there in the last 2 weeks. The tallying votes and awarding unique indexes. So this is actually like a big part of the system is like, okay, the vote is over. What actually happened? So that had not yet been started 2 weeks ago, and now it's in progress 70%. And this one we had on the slide as not yet started. The next one, I kind of decomposed it into two. From tallying votes and awarding unique index. It's basically awarding the document. And I split it out, and now we have cleaning up and storing the vote poll info because it's big enough to like, not all group up as one thing. The queries, while it looks like, queries did not advance that much, it went from 45% to 65%. It's actually that we originally were going to do 4 queries, and I think now we're going to do 7, if I'm not mistaken. So that's why a lot of new queries were written. Just some extra ones are now also have to be written. And that's why. The SDK integration, I had not put it in this feature mainly because in the past when we wrote features, we did the SDK integration as a different feature. But yeah, I thought that now where we're at as a project, we should put it in. So yeah, we did some stuff there. Since I don't have a slide on SDK integration, I'll kind of explain why it's at 35%. We did the Masternode votes, so you can do the state transitions. You can publish them from the SDK, and you can query the system for 1 out of the 7 queries. That's why 35%, but it's one of the more complicated queries. It's actually the most complicated query I think that was done. Well, there are 2 that are very complicated, but once one is done, I think it will get easier and easier. Okay, so let's go on, and I will yeah, explain here what has happened here in Masternode vote state transition. The insertion went from in progress to being done. The identity query references went from being in progress to being done. The removal, if the masternode is taken down, went from, wait, I might have that actually. You know, so much has happened in the last 2 weeks that this one might actually be there. So I'm not sure. I have to check. Okay, and let's go on. Yes. So what queries can we do in the system? So basically getting the identity votes for a specific query, like what votes does somebody have, Balash in this case. That one was in progress. It still is in progress. I didn't finish it yet. Get current conflicting vote polls for a contested unique index. So this is, for example, like what votes currently exist in the system. Like, can I, for example, for names, what names are currently able to be voted on? That's done. Get vote polls that are finishing soon. That's also done. Get tally information for a specific vote poll, so like who is winning. That's also done. And this tally information, it actually is a quite interesting query because you can actually request it either for with the tally information or without the tally information. If you requested it without the tally information, you basically just get the documents the different people have are putting forward for the vote. So it might, I mean, it basically is 3 queries in one. And if you do it without the document information, you basically just get back the identities who are participating in a specific vote poll. I know this stuff is quite complicated. It will, once it's out as a feature, it's going to be a lot better. So get who voted for a specific vote poll. That's like, okay, inside who voted for Balash, it's not exactly the same query. Wait, get identity votes. Oh yeah, so get identity votes, the first one, which votes does Balash have? It's like Balash is the one voting. What did he vote for? The other one is there is a specific query. Let's like vote poll. Let's say it's for a name, Coca-Cola, and a few people are trying to get that name. Who voted for somebody to get that name? That's the last query. Get remaining balance for voting on a specific poll. That one has been done. So that's basically when you create the contested resource, it requires you to put money for it. And there's a balance that is being used by masternodes and evo nodes to vote, to actually vote. So yeah, and you need to, you can query to know the remaining balance. So yep. Get finished vote poll information. Yeah, that has not been started yet. That is after the vote poll has ended, you can keep information about all the people that voted for it, how it ended, like who won, etc. And a lot of extra information that, yeah. So queries, that's queries. Now let's talk about the award to the victor. I put in review here because while everything actually has to be reviewed by Ivan, good luck, Ivan. In review basically means that I need to do another pass at it to, I wrote the code. I just need to self-review it. And so what do we have right here is we're awarding the document to the winner at the end of the contest. That's done. Like, the code is written. I would like to, write some extra tests for it. Check for ended contested resource vote polls. So this is actually before. So it goes, I put it in the wrong order. So it starts with, okay, what has ended in since the last block? Okay, I found that these different ones have ended. Okay, inside each one, who has the most votes? That's number 3. Okay, this person has the most votes. And then the person that has the most votes gets awarded the document. So, and somebody asked last time, what would happen if there's a tie? If there is a tie, it goes to the person who created it first. If the 2 created it first, it goes to the identity that, it goes to the document that randomly has, well, pseudo-randomly has the lowest value of the ID. Now, could you game that? A little bit, you could. However, I believe that we're talking about a situation that would be very, very, very hard to actually occur. And you would have to be able to go through a lot of hashes really quickly before one block happens to be able to game it. I don't actually think that it is possible to, I mean, it's not something that will actually occur, I don't think. So the last 2 have not yet been started. It's the delay vote poll and the lock vote poll. The lock vote poll is basically for contested resources that you want to vote to not award ever. And the delay vote poll is something that I might do, I might not. I prefer putting on everything here, even if I decide to remove it. It's the option that I'm voting that I don't really want to lock it, but I don't want it to go to anybody that has currently wants the contested resource. So for example, maybe Coca-Cola is a good option, right? So Coca-Cola comes out and the identities that are trying to get it are not the Coca-Cola company, and most Masternode voters want the name to actually go to the company. So they could just vote to delay. And that basically means that the people trying to get it just would not get it. Yeah, cleaning up. Because we have all this information in the state, and at the end of the vote, you have to clean it all up. So I wrote that, and it's the code is done. This is new stuff in the last 2 weeks. But one thing that hasn't yet happened is the record of the vote poll and the result, so we can do the query later. So that hasn't yet been started. Okay, so that is Masternode voting. I'm kind of sorry that it isn't done yet. 7,000 lines to 8,000 lines have been written the last 2 weeks. I'm gonna be done soon, some point soon. Okay, thank you very much. I will pass it to Ivan.
Ivan.
Good progress, Sam. Thank you. Hello, everyone. So this work is continuation of the work what actually Sam started long ago. You probably remember the state transition validation document, what we discussed when we write down all the validation logic, and Sam revisited many state transitions, and I took the data contract create and data contract update transitions to review the validation logic. This work was started actually 2 sprints ago, but I haven't reported it last demo because I was sick. So I have a chance to do it today, fortunately. So it's pretty big amount of stuff here, so I will just go briefly, if you don't mind. During the review, there were done some bug fixes, optimizations, some little bit refactoring. So I will go through it really quick. I will probably pick the most interesting bugs what was fixed. For example, the fixed missing data contract owner validation. Basically, previously, anybody could update anyone's contract. So that's pretty bad situations. So yeah, I can update the contract what Sam is created, for example.
No, don't update my contract.
I won't anymore because it's fixed. So yeah, you were able, for example, to remove the document type from the contract what already exists that could lead to invalidation of all previous documents stored in the state. So basically broken documents, broken contract. What else interesting here? Yeah, I could change the configuration of the documents. For example, it was, I don't remember what exact settings I could change, but basically I can change the behavior that could break the state. And many of these errors could lead some internal errors. Some of them will lead to the corruption in state. So basically we store the invalid data in state and we try to retrieve it. It will lead to errors and things like this. What's interesting here as well? Yeah, I could create the contract with like any version I can figure out. For example, the maximum use U32 integer, so you won't be able to update contract anymore. Or I could create the contract that uses array, but we don't support array for MVP, but I still could do that. And this array will be encoded as array of booleans, so that will make the documents invalid. So things like this. What else? Could you please go to the next slide, Balazs?
Sure.
Yeah, there are like several optimizations were done. Nothing like super critical that will speed up like 50% or something like this, but like multiple small optimization that in overall will speed up the state transition execution and reduce the fees, I guess, in the future when we calculate every operation. Yeah, it's too technical, I think. Let's not go through it. If you guys have any questions regarding this, I can get in details after the presentation. Yeah, and the good news, the data contract transitions validation is covered, like this test now. So we have like full coverage, and the small refactoring was done to move the data contract update validation to DPP. So now we in SDK we can validate the data contract, the update of data contract before we broadcast it to the network to make sure the update is that the new data contract is compatible. The interesting thing also that we had the redoes attack vector in our data contracts. Redoes, it means like regex so you can form the regex in a way that it takes like way too long than other operations. And basically you even could make a contract with a lot of our patterns. There is a keyword in JSON schema named pattern, so you can put the regex inside, and to validate the input string in document. And you could create data contract with document type that defines 255 properties, and they all strings with the very complex regex, especially if they're using the look back logic and back references. That's pretty slow, and the proposer basically won't be able to propose a block in specific timeout, and so that could lead to chain hold basically. And to
I have a
fix that,
question.
yes.
Sorry. Didn't we already have a smaller regex library that we were using?
Yeah, so initially it was done in JavaScript implementation of DPP. We used this re2 implementation of regex engine from Google that basically guarantees linear time of execution. So it's like O n plus m, where n is size of the regex and m the size of payload what you're validating. But when we migrated the port DPP to Rust, we lost this functionality. So we used the built-in regex engine in JSON library, in Rust JSON library, what we used. But though we still had this validation around the schema that we're using, this re2 syntax kinda, but we actually did not. And that was one of the optimization to remove this traversal validation logic. So yeah, and this JSON schema implementation in Rust, it uses the fancy regex library that basically allow you to do this look back and back referencing, so that could lead you to. So basically, it's open for attacks. It's vulnerable, and what I did, I replaced it back to the regex crate. I would say it's more like standard regex implementation for the Rust, and this do not support this fancy complex functionality, but it's based on re2 logic algorithms, so it guarantees also the linear time of execution.
Thanks for the explanation. I do want to just point out that when you wrote covered with tests, it didn't mean that there were no tests before. It just means that you added a lot of unit tests, right?
Yeah. So there were tests for sure, and sorry, I probably should rephrase it. So what I mean that I covered basically the accomplished to almost 100% coverage.
Excellent. That's awesome. Thanks.
Yeah. And all this validation logic is documented in the state transition validation document that's at some point, I believe, become a deep, right, Sam?
Yes, actually, yes. Very soon, hopefully.
Yeah, cool. Another topic for us this sprint was the core RPC security. That what Sam announced at the beginning of the demo that we have this identity create state transition, and the problem with basically the issue what we need to fix. And we should look back actually on and in more general approach of using the core RPC, because the core RPC is never meant to be used as the public interface and to handle some like load, and especially like triggered by multiple users. So it was always, you know, something with like single user thing, and for debugging or like simple tooling. And now we're using the core RPC in platform in many places. And our goal here is basically review, revisit the code base and see where we're using core RPC and how we're using it, like how frequently, what comments do we use, how these comments are the resource consuming and things like this. The problem with core RPC is that it's basically a single queue of the comments what you populate with the HTTP call to core, and it's more like single-threaded thing. So the performance is quite limited, and if you produce a lot of calls there, you can overflow the queue, because the queue also has the limit. So yeah, that was the topic, and we documented all the comments what we found in the platform and how we use it. We analyzed and benchmarks some of them thanks to Pasta, with help, and this work ongoing, and there are many parts where what we need to investigate still, but many of them already located, and we are working on fixes. So first of all, what we did, so there are three components what are using for RPC. It's DAPI, it's standard dash, and drive ABCI. DAPI serves some user requests like get transaction, get blockchain status, and things like this. DAPI drive is executing blocks, and it needs some additional information during the block execution, for example, the quorums, chain locks, and it also verifies the instant locks for identity create and top-up transitions. So there are some work happening there. And we have Tender Dash, and Tender Dash uses the core for signing and to obtain some quorum information. So at the moment, we found several, I would say, the critical problems in DAPI and one in Drive ABCI. The list of tasks, what you see here, it's not complete. We still have some of them on our board, and we're still investigating some of the comments. So we will come back to you next demo with updates, that's for sure. But currently, what we have done, we disabled all endpoints in DAPI, what we are not using right now for MVP, just to basically reduce the scope of our work. So we don't need to look at everything. Currently, we disable get block, we disable get blockchain, gets masternode status, and we also had the generate block actually in DAPI that was removed completely. It seems like we had it for testing before, some legacy stuff. We also found the place where we're calling get transaction in transaction stream, calling like hundreds of thousands times for each stream. That's what we replaced to the get multiple transaction call, just in one call. I mean, it will be in several calls, but still like 100 times less. And get transactions pretty fast. So that's basically this problem is mitigated. Also, we found that get masternode list diff, what we're using to obtain masternode, the simplified masternode list for DAPI client, it's pretty slow. So instead, we are introducing a streaming endpoint when DAPI client don't need to call get masternode list diff multiple times. Now it's like calling every few seconds to get updates. In case of stream, you will just connect once. You will get as the first message the full diff from the first block to the tip, and then each block, the new updates will arrive to the client. And we use the global cache in DAPI for all requests. So the request itself from the client doesn't initiate any RPC calls. So it's more like the push system rather than pull. Yeah. Also, we noticed that get blockchain status is using everywhere to get the actually current tip, and get blockchain status is slow. We have a separate task for this, but we introduced specifically for this need get blessed block height to get the current tip. And this one won't initiate any RPC calls as well, because it will be a global cache with the push system. The push system, I mean the DAPI listening for updates from core with the MQ socket and update the cache automatically, so it doesn't use RPC basically. Yeah, blockchain status will be optimized as well. This in progress right now. We will introduce the cache, so we won't call for every request, so that won't be an attack vector as well anymore. And currently, the last thing what we're working on right now is the testing of one of our theory that's basically client or some massive botnets, like when you do like DDoS attack, since like the DDoS attack won't be possible in this case because we have rate limiter in gateway. But if you having like a lot of IP addresses, a lot of machines, you can initiate a lot of requests from the in DAPI or in Drive ABCI, and that will produce a lot of RPC calls in turn to the core. And those calls they overflow the core RPC queue. So that could lead to situation then the actual critical functionality, for example, the block production. So we're using core for block production in platform, right? And that will be paused because the queue is blocked or even errored. So it could lead even to chain halt in case if queue is just reach the threshold, the limit. So yeah, that's what we are investigating right now. Thank you, Balazs. I felt like I just like live through these problems right now while I'm speaking about it emotionally. Okay, and the another task what we implemented pretty handy this sprint is very useful for load testing, what we continue to do, and there won't be one more. We calling this long running test when we like populating data to the platform during like months or so and see the system works It will be another one when we testing the queries. So this new functionality is basically the observability, the transparency on what's going on with transactions in our system. So now we have a pretty comprehensive logging. So how we add transactions to mempool, how we remove them from mempool, what transactions are invalid, which are not, the execution time of those transactions, and also during the block production. When we execute the block, we're also measuring how much time the validation took. We're also storing the fees, what we're taking, and are not sure about the fees, to be honest. I remember, but yeah. So all the information what currently we have, we store, and I think next demo we will show you nice graphs, nice visualizations in Grafana. So yeah, that's very helpful for testing and see what's actually going on in our system and what needs to be fixed. Thank you, Balázs.
Thank you very much. Let's continue with Paul and the strategy tests.
Yeah, hello. So last time I left off, we were seeing some state transitions failing in the mempool in strategy tests, even though they were broadcasting fine. It was like after a few minutes of being in the mempool, they would fail, especially towards the end of the strategy test. And so I was investigating that, and basically just we found that the identities were running out of balance when the transitions were in the mempool. So a simple fix, just fund the identities more. We suspected that it might have also been nonce errors happening in the mempool, because like state transitions would be included in blocks in sort of random order, and then maybe the nonces would get out of order. So I added like a safeguard in strategy test to prevent that. Basically, the identities can't submit more than 24 documents per contract into the mempool at a time. So just an extra safeguard, even though that wasn't the issue in the first place. I also added an error type counter for strategy tests. So like basically at the end of the test, when you get the results, it'll, if there's like 100 nonce errors, it'll tell you how many errors, nonce errors, how many timeouts, all that stuff. I enabled an option to top up identities if they run out of balance. So if you are doing like a long strategy test and some of your identities run out of balance, you can opt to have them automatically be topped up, and you can determine how much dash you want to fund them with. If you choose not to top them up, then I made it so that you don't submit transitions from those identities anymore if they're out of balance. So that will prevent some errors. And yeah, if all of your identities run out of balance, then the strategy test just stops. And it gives like a result that says strategy test was partially completed. I also so we're preparing to run like a long running strategy test. Like I think we were trying to do a month long. So I basically just got the number for how much dash it will cost to do 50 transactions a second for 1 month on a DevNet, and it's 37,000 dash. So yeah, we needed to figure that out. And I also ran a 3-hour test on testnet at 20 transactions per second. And I just included that because before now, I'd only been doing 10-minute tests. And so we successfully did a 3-hour test, and it went very smoothly. All the the transitions were being processed just as fast as they were being broadcasted. So that's good. The reason I only did 20 is because we have, like, on testnet, we have rate limits set. So if I went over, I think if I did 30, it would have given a bunch of rate limit errors. So we know at least that 20 transactions per second works very well on testnet. And I think in the next few days, probably this or next week, I think we're going to start the month-long test on a DevNet at 50 transactions per second. So that will be interesting. And yeah, everything is done on my side, I think, for getting ready for that test. So I'm going to begin working today on adding some of the things that Sam is working on with masternode voting, adding that to the TUI. Basically, being able to vote on certain contested documents from the TUI and stuff like that. Yep, so that's it. Thank you.
Yep.
Thank you very much.
And just so if people miss that, so if platform was released with our current fee model with no improvements or changes to the fees, and it was fully like it was at max transactions per second for a month, it would generate 37,000 Dash in revenue. Well, maybe not in revenue, yes, in revenue, yes, not in profit, right? Because there's going to be costs associated to the Evo node holders, but quite a lot.
Yeah, and that's assuming 50 is the max too.
Yeah, that's assuming 50 is the max. Good point. Right. So, yes. Later down the line, this might be quite profitable.
Yeah, thank you very much.
What?
Shall we yeah,
Sorry.
Paul?
Let me just
Please.
get the dollar amount. 37,000. What's the price? $30. That's $1.1 million. Okay.
Yeah.
Thank you. Audie, would you continue with GroveDB State Sync?
Yeah. So hello guys. Progress was made also in GroveDB State Sync. So on GroveDB side, the implementation is done, and the optimization of multiple subtrees in parallel. Well, this one was done in the previous sprint. During this sprint, the work basically of the integration of GroveDB State Sync in platform MBCI was completed, and it is currently in review. I have to give some big credits to Evgeny because he helped me a lot with some difficulties. Basically, we needed some advanced Rust features to this code in order to use the state sync feature. I don't want to go too much into details. Basically, in one sentence, it was really hard to hold the reference of the transaction of the state sync feature and being able to use it in all the places in ABCI. So thanks to Evgeny, this was bypassed, and we are in review state as it is now. So the next step would be, of course, to merge the PR, so and proceed to testing state sync status. Sorry. So we will, of course, we will do a very deep testing and multiple scenarios that we are going to think about. So we'll start in in a state sync locally, and then eventually we'll finish this by testing this on testnet. Last, as I already told, the checkpoint mechanism. So the ability to being able to resume at some specific points if there's, for example, a network failure. This one is also in progress, but I think this one will be completed after the main testing of the base implementation, let's say. So yeah, that's pretty much. It is on the, I would say, on the final turn, if it was a race. So yeah, thank you, Balash.
Thank you. And let's continue with the core team. Costa?
Thank you, thank you. So yeah, this week or this last 2 weeks really just continued with backports, moving forward with networking, refactoring for BIP 324, as well as helping out platform team a little bit with looking at RPC stuff, figuring out maybe some optimizations that we can do to ensure that the queue does not kind of get full or anything like that, and try to optimize that for them or do some profiling and see if there's any options there. Really, the biggest thing was moving forward with BIP 324. Constantine did work a little bit more on hardware wallet support, but no major progress. No like reportable progress really was made on it. We did have a good chunk of backports done in the last 2 weeks. Still working on getting C++20 requirement figured out. There are just some weird dependencies that we're working through there. Yeah, I think we can move on to the next slide. We can see here, basically everyone's on v20.x and about 40% on version 20.1, which is nice and dandy. Actually, I don't know if I updated the Evo node count this sprint, so we might have a couple more. We can move forward here and take a look at the PRs that emerged in the last 2 weeks. You can see the vast majority of them are Bitcoin backports. We do have a couple other things open right now that are not Bitcoin backports that we're working on. We're working on a potential stabilization fix for some of the governance stuff on testnet. It's not an issue that we really ever see on mainnet, but on testnet every once in a while, because superblocks happen so frequently, a chain sees the superblock before they saw the trigger, and that causes issues. So we are working on a fix that should help stabilize testnet governance quite a bit. Kudos to Eugene for working on that one. And I think we can move forward and go over to mobile.
Yeah, thank you. Brian, would you kick us off with mobile?
Yeah, thanks, Pasta. And Blush. All right, so on Android, finished everything that we planned for the most part there, and that includes the Rust support for document objects, and really mostly some maintenance on Dash Wallet, and the still picking away at the Maya integration there a little bit. Can move on to iOS. A little bit more ambitious with iOS. A lot of Rust work was being done, and kind of things got split up throughout the sprint. We didn't actually plan for all of that. It ended up being broken apart into a few different things, but made some real good progress. The Coinbase change, so we had to go a little bit further than we did than just restricting it to UK storefront users. We had to prevent any user that is located in the UK from using Coinbase. So there will be a that will be coming out in the next release, where you'll have to grant permission for location in iOS if you want to use the Coinbase feature, and it's you can do it just for that one moment. But if you don't grant the location access or permission, then you can't use Coinbase in iOS. The alternative was to just take Coinbase out of the app entirely, but we didn't want to do that, at least not at this time. On Dash Wallet, we had a similar stale rates warning that we did on Android, and a crash in CrowdNode, and still pretty good progress made on CoinJoin. That's it for mobile. Oh, we also started to release the mainnet version of DashPay with CoinJoin. So for those who still want to participate, we have that going on mainnet now on Android.
Thank you very much. Thank you. Let's continue. Let's continue with the questions. So we have one question. Thanks, Shenlik, for the question. Hello, team. Can you please tell us about encryption features that will be available at V1? I've seen something about that, but is it possible to use it with in conjunction a document transfers? With conjunction on document transfers.
Sure. So tell us about encryption features that will be available in V1. So inside of documents, right, you have fields that can hold data. And because they can hold data, that data can be encrypted. It's not a feature of the system so much as it is like the system does not encrypt. It's the client that encrypts and adds the data. So you can encrypt, and we have like encryption, decryption keys specific to data contracts, and you can register your encryption and decryption key for the specific data contract or for a specific document type. But it doesn't happen automatically. It just is giving the information to clients to use those encryption and decryption keys. When you say, can we use it in conjunction with document transfers? I don't exactly know what you mean. I'm going to guess you might be thinking that encryption could potentially hide who's sending who to what, but that's not possible with just encryption. So
yeah, thank you. We have another question. Once masternode voting is completed and tested, it will need to be integrated into the DashPay wallet. Can you talk about that? Will this be a lengthy process?
Yeah, I can speak to that. So we've actually already built the majority of all of the UI front end in the mobile wallets for voting, both for voting and for submitting username requests. So we've just been waiting for the back end to be done. Once that's done, then we'll do the final step, which is just tying into the voting system essentially that Sam's been building. Yeah, so we're just on our way there.
Thank you very much. All right. I don't see further questions. So thanks for being here. Thanks everybody for joining, for the questions as well. And hopefully we'll see you in 2 weeks. Thanks everybody. Have a great one. Bye-bye.
thanks, guys.